Hello again. Welcome to Pre-Calculus Trig, Section 1.2 on right triangle trigonometry. This is part 2 of the lecture. We're going to do a few more examples. In this example, we're asked to find the exact value of segment DE. So this here is segment DE. BA and BC have length 4. So those are these two hypotenuses right here. These are both of length 4. So this is a triangle on top of a triangle problem. So the best strategy for these is to pull them apart and draw them separately. So let me do that first. So I've drawn them separately. Now I'm going to put my information, my numerical information on them. So I'm given that I have a 4-meter hypotenuse on both of them. So I'm going to write 4 here and 4 here. I'm given that I have a 30-degree angle for this triangle here. So CBE is 30 degrees. So 30 degrees here. And I'm given that this angle from this line right here all the way up to this line right here is an additional 15 degrees. So I've got 30 plus 15, that's 45 for this angle DBA. So 45 here. All right, that's all the information I'm given. So from what we've learned about solving triangles, if you have 1, 2, 3 pieces of information, you can find any of the remaining 3 pieces of information for a triangle. Same here, 1, 2, 3. So I should be able to find anything else I'm looking for on either of these 2 triangles. So let's come up with a strategy as to how we're going to find DE. So what I'm noticing is if I could find the length of BE and subtract the length of BD, that'll give me this small length DE. So that's the strategy I'm going to employ. So that means I got to find this length and subtract those 2 lengths to give me DE. So let's work on BD first. So if I'm standing on the angle 45 degrees, this is my opposite side. Then this is my hypotenuse, and this is my adjacent side. So I can come up with an equation to solve for BD, my adjacent side. Remember, in my equations, I always want to have only one unknown. So if BD is my unknown, then I'm going to want to use 4 in the equation. So I can say I need adjacent and hypotenuse. So that indicates I need to use the cosine function so that I can put in the 4 and the BD. Right, so let's set that up. So I can say the cosine of 45 is equal to adjacent, so that's BD, over hypotenuse, that's 4. So if I do a cross product here, I've got 4 cosine of 45 is equal to side length BD times 1. So that means if I divide by the cosine of 45, I should have, I don't have to divide this time. I can just punch it right in. 4 cosine of 45 is BD. So I got BD by punching it in is equal to 2.828. Right, so now let's go ahead and find BE. So if I look at my triangle here, I've got the same given information. I've got this angle similar to how I was given this angle, and I've got my hypotenuse. So I can use my same equation with a different angle in it. So I can say the cosine of 30 degrees is equal to BE this time over the hypotenuse, which is 4. So that's adjacent. This is adjacent over hypotenuse. All right, so that means, again, I'm going to do my cross multiplication. So 4 cosine 30 is equal to BE. So I'd want to punch in 4 cosine 30, and I'll get that BE is equal to 3.464. All right, so my strategy was to subtract those two numbers to find DE. So DE is equal to BE minus BD. So 3.464 minus 2.828 should give me that length. So I'm getting 0.636. So if I round that to, let's round it to the hundredths place here, 0.64, and we're working in meters here. So that's how long line segment DE is. So this example says a metal plate has the form of a quarter circle with a radius of 100 centimeters. So that's out to the edge. 2 3-centimeter holes are to be drilled in the plate 95 centimeters from the corner. So here's the corner. So 95 out to here. So that's your radius of 95. So you could swing it around like this. You could see that the radius to the center of the holes is 95 centimeters. All right, so they're to be drawn at 30 degrees. So here's 30 degrees and 60 degrees from the corner as shown. To use a computer-controlled milling machine, you must know the Cartesian coordinates of the holes. So that's your XY pair of each of these holes. So this is X1, Y1. That means for hole number 1, the XY coordinates, and for hole number 2, the XY coordinates. Assuming the origin is at the corner, so that's right here. What are the coordinates of the holes? These pairs rounded to 3 decimal places. All right, so if I enlarge this a little, I can see that my radius, 95, is here and also here. All right. So I can create some right triangles by dropping a perpendicular down here, like that. And so I can see that this is X1 from the origin here out to right here, and that'll give me this X coordinate here. And I can see that this is Y1 from here to here, and that'll give me this coordinate here. Now what I can also see by symmetry is that this is the same triangle. So if you flip this triangle around so that this side is now this side, you can see that this side is going to lie on top of this side, and this side is going to lie on top of this side. All right, so that means if I can just figure out what X1 and Y1 are for this one triangle right here, then this X1 becomes this dimension here. So this is now my Y2, and this short dimension here is now this dimension, which is X2, so they'd be switched. So I only need to do one triangle here, and I've got the two numbers that I need. All right, so if I pull that triangle out of there, so I can draw on it, I've got 30. My right angle is here. My radius is 95, and that corresponds to my hypotenuse. Right, and this is X1 on this side, and this is Y1 on this side. Right, so standing on my 30-degree angle, that means this is my opposite here. This is my adjacent, and this is my hypotenuse. All right, so I can say sine of 30 is equal to opposite over hypotenuse, so y1 over 95. So if I do a cross product, I've got y1 times 1, which is y1, is equal to 95 sine of 30. So I can plug that into my calculator, and I get 47.5. Right, so that's y1. All right, now let's find x1. So x1 is on my adjacent side, so I'll be working with my adjacent side now and my hypotenuse. So that means I need to use the cosine function. So the cosine of 30 is equal to x1 adjacent over 95 hypotenuse. So setting up a cross product, I'll get x1 times 1, which is x1, is equal to 95 cosine 30. So plugging that into my calculator, I get x1 is equal to 82.272. So 82.272 is x1. So I've got my coordinate pairs. I've got x1, y1 is 82.272, comma, 47.5. And then I would switch the order of the coordinates for x2, y2. Because it's the same triangle turned up on its end. So there's your answer to that example. The next thing we'll talk about is angle of elevation and angle of depression. So we've got an observer here. So at their eye level, you imagine there being a horizontal line right at eye level. So, for instance, if this was a bird in the sky, you would have to look up from the horizontal in order to observe the bird. So that's considered an angle of elevation when you're looking up to see the object. Now, on the other hand, if you have to look down to see the object, like if you're up in a tower looking down and observing an object on the ground, then you're looking down from the horizontal and you're sighting an object at a certain angle that's below. So it depends on whether you're looking up from the horizontal or down from the horizontal. So in this problem, an observer in a Coast Guard tower on shore sights a boat in trouble 1 mile from the shore at an angle of depression of 3 degrees. He also sights a rescue helicopter directly above the boat at an angle of elevation of 5 degrees. How far above the boat is the helicopter in feet? All right, so let's draw a picture. So first we have a tower on shore. So here's the ground over here, solid ground. And then of course we have a boat in the water out here somewhere. All right, so now we have a boat. Out here in the water. All right, let's make the tower a little bit shorter so I have enough room for the helicopter. All right, so he spots that boat out there. So here's your horizontal line for your angle of elevation and depression. Got to have a horizontal line through the line of sight there, through the person's eye. All right, so he's spotting this boat out here from up there at an angle of depression, so downward, of 3 degrees from the horizontal. All right, then he also spots the helicopter up here spots the helicopter. So let's draw, he's looking up this time from the horizontal 5 degrees. So that's your angle of elevation. Alright, so we're asked how far above the boat is the helicopter in feet. Alright, so above the boat, how far, let's call it H, how far above. Alright, so that's the number we want. Alright, so we got to make some right triangles out of this. So here's one. The tower will make a right triangle with the ground. The tower is assumed to be perpendicular to the ground. And then we've also got this dimension here. Let's just draw this right down to the boat here. Right there. So we've got some triangles here to work with. And we have a dimension. We have to put on our 1 mile from the shore. So from here to here is 1 mile. Okay, so we have enough to work with now to find out our height there. So I'm going to color these 2 triangles that I see here. Got this triangle and the green one. Right, I'm going to say that if we can figure out what these 2 sides are, here and here, we can just add those together and we'll have H, that distance from the boat to the helicopter. Alright, so in the 3-degree triangle, here's a right angle here, and in the 5-degree triangle, here's a right angle here. Alright, so 1 mile in terms of feet, we're supposed to be working in feet, is 5,280 feet. So I'm going to stand on my angle 3 degrees, and if I draw an arrow, I'm just going to imagine it so I don't make my drawing too messy. This is my opposite side here, and then this 5,280 feet is this distance from here to here, which is my adjacent side. So if I'm working with opposite and adjacent, that would be tangent. So I can say the tangent of 3 is equal to, let's call this A and this B. The tangent of 3 is A over 5,280. So I can say that A times 1, which is just A, is equal to 5,280 tan 3. If I punch that in the calculator, I get 276.713 feet. Alright, so that's one of the numbers. Now let's do something similar for the purple triangle. So from standing on this 5-degree angle, this is my opposite side, and the same side here is my adjacent side, 5,280 feet. So once again, I can say the tangent of 5 is B over 5,280 feet. So the tangent of 5 degrees is equal to B over 5,280. So B times 1, which is B, is equal to 5,280 tan 5. Typing that into the calculator, I'm going to get B, 461.94 feet. So I add those 2 numbers together. So my H is equal to A plus B. So H is A plus B. Add my 2 numbers together, and I get 738.65 feet, which is the distance from the boat to the helicopter. Here's my last example. I want to measure the approximate height of a tall tree. The ground is close to being level. I measure the distance from where I am standing. So here's me, my person, to the tree. So that's this distance here as 55 feet. I cite the angle of elevation to the top of the tree, right here, as 52 degrees. I am 6 feet tall. How tall is the tree in feet? All right, so let's enlarge this picture a little bit so I can draw on it. All right, so the person is 6 feet tall. All right, so this will be your right angle right here. And the person says they're 55 feet from the tree. So that's this dimension here to the person. Right, so that's the same as that dotted line. Those are both 55 feet. Now it did give an angle. It said it was 52 degrees angle of elevation to the top of the tree. Right, so 55 degrees here, 52 degrees actually here, angle of elevation. All right, so we want to know how high the tree is, how tall the tree is. And the other thing we're told is that this person here is 6 feet tall. Okay, so I'm going to find out what this dimension is here, and I'm going to add it on to the 6 feet, and I should have the entire height of the tree. So if I'm on my 52 degree angle, that H is my opposite side here. Right? And this 55 is my adjacent side here. That dotted black line right here is 55 feet long. Alright, so if I want to set up a trig equation, I want to use my adjacent and my opposite sides. So that's tangent. So I'm going to say the tangent of 52 degrees is equal to my opposite side over my adjacent side, which is 55. So that means H times 1 is equal to 55 tan 52. So if I type that into the calculator, I get 70.397. Alright, so if I add on to that my 6 feet, remember, so it's already 6 feet to this point on the trunk here, so this is 6 feet, then the additional 70.397 feet, that should give me the total height of my tree. So I add the 6 feet on to the 70.397. I rounded it to the 10th place. That's 76.4 feet. So that concludes part 2 of our lecture. You should be ready to try your homework problems for section 1.2. Let me know if you run into any problems.